I'm so sorry. I forgot to hit record until I got to part C on this. I'm going to recap part A and B really fast. You'll all be okay. So for this one, your initial condition was 3, or is it point to it? 3 plus, and then your accumulation starts at 4. So 3 plus, and then 4 to wherever. So 4 to 0. We came up here and found our areas. That one was 3 plus 2 pi. This one was 3 plus a half. Here we get 2 and 6. Your derivative changes from increasing to decreasing or decreasing to increasing there. Cool, got us caught up. I'm sorry, I forgot to hit record right at the beginning. All right, part C. Introducing a new function. They love to do this. Introduce something new halfway into the problem. G equals f of x minus x. Okay, so this is now the function that we are looking at. On what intervals, if any, is G decreasing? How do you tell increasing and decreasing? Yeah, derivative is positive or negative, right? So the first thing we're going to have to find is G prime. So G prime would be equal to what? F prime minus 1. Good. If you wrote that, you get a point. Good job. Now, do you have an imagination? You have the graph of F prime. You have to imagine it being moved down 1 unit. Okay, so look, it sounds like you guys got this. If you take this and you move it down 1 unit, can you imagine that? Where would that graph be negative or below sea level? From 0 to 5. Good job. So you're going to say G of x is decreasing 0 to 5 because G prime is negative there. And then that sentence was worth a point. But if you even got the f prime minus 1, then you got 1. Okay? Part D asks for an absolute, and they were nice. They threw the word absolute in there. Sometimes they don't. All right. What test is this? The candidates test will be on there. If you do all 6 free response and you haven't done a candidates test, figure out which one has a candidates test. It is on there. Okay. Who are your candidates? Oh yeah, endpoints and critical points, which are 0 and 7 are the endpoints. Now, again, you have to imagine this moved down 1. So the other place would be 5. And then 7 would also hit the x-axis, but that's the end of your interval. So 0, 5, and 7. Now, you get a point for writing G prime equals 0. Did anyone write G prime equals 0? Oh, that is such a bummer. Because what that means is, listen, that means you know what you're supposed to do. And sometimes they will let you interchange f for something else. But in this case, there's a different function that's f of x. So they won't let you interchange those. So just be really careful. All right, so G prime equals 0. Good news. We already did f of 0 and f of 5. And they do this sometimes so that you don't have to go back and redo more work. What was f of 0? We did it back in part A. All right, so it's 3 plus 2 pi minus 0. Now I realize it's 0, but do you see how this G of x is whatever you got for f of x, but then minus x? So it's minus 0. What is that approximately? If you think of pi as being about 3, it's about 9. Now, if that ends up being the answer, don't write 9. You still need to write 3 plus 2 pi. That's just so we can see about what it is. All right, so I don't have to move the paper up and down anymore. What did we get for f of 5? It was 3.5, and then you have to minus 5. You have to minus that x value. So that would be negative 1.5. This one we have to actually work out. Look back at part A, because it's going to start with the same setup. It's going to be 3 plus integral what? 4 to 7. Good job. F prime of x dx. And then you would have to minus 7. Good job. So let's see what that's going to be. 3 plus, all right, what is your area from 4 to 7? I will bring the paper down for this. If you add all this together, 3.5. And then minus 7. So what is that? 6.5 minus 7, negative 0.5. I forgot what they're asking for at this point. Did they want a maximum or a minimum? minimum. So we're going to say absolute minimum is, what's the lowest number? Is negative 1.5 at x equals 5. That's your answer. So it was a point for writing g prime equals 0. And it was a point for that answer with justification, which is the table. Did I get it to add up to 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. Basically all the time. If you're not sure, write it. Because they made it worth a point. So if you're doing a candidate's test, you need to write it. Okay. Here's what we're going to do. I'm going to pause the recording and I'm going to give you 10 minutes. Normally it would be 15, but I want to finish all of these today. So I'm going to give you 10 minutes and then we'll go over number 4. All right. What are they giving us in the table? Let's focus. Centimeters per day. So it's already a rate. It's R prime. So this ice sculpture that's in a cone, I don't know why you would want to own ice sculpture, but anyway, is melting. So do you see how these are like they're negative? Anyway, twice differentiable. R of t is in centimeters, time is in days. Obviously the centimeters per day. They give us values from 0 to 12. That's all that is saying. Approximate, because you can't get it exactly, because you don't have a function. All you have are these random numbers. R prime of 8.5. What are you going to do? Slow. Which 2 points are you going to use for 8.5? Yeah, good. Do not be too proud to write them down. This is where it's worth, I tell you to not kind of cut corners to save time. Not here. If you mix up 2 numbers in a slope, that is a sad day. All right. It should be negative 3.8 plus 4.4 over 10 minus 7. I think that might have been a point by itself. That was a point. If you wrote that, that's a point. Now they also wanted units. Those are a point. So what do you think? Per day squared. Good job. That was worth a point. 2 for that. Did you get the units? You're not going to do it on the test, though. Do you see how that works? You need to make your mistakes now and make them loud and figure them out and then not make them on Monday. Go ahead. No, in fact, that's better.
Okay, so we have that, but then we went extra and then we made the line of tangent, but if we got those ones that even
I'd like to believe that they would give them both to you, but that is a direction following error and they may only give you 1 out of 2. Oftentimes, and this is how this works, if you provide 2 answers to a question, what they typically do is score both, average them, and round down, which oftentimes rounds down to a nothing because one of them is wrong. So you may end up being in a 1 out of 2 because it's a direction following. I would give you 2. Again, why I would be a poor grader, but I feel like if your answer's there, you got it. I would give you 2. This is a theorem. Do you know which theorem it is? It's either IVT or MVT. Good, perfect. All right. Is there a time from 0 to 3, that's here to here, where this equals negative 6? Well, is negative 6 in between these? Yeah, so here, ready, buckle up. All right. Since R prime of t, I'm trying to write fast, is differentiable. And I want you to write out that whole word. I've been taking diff and con up until now. I don't know that they'll take those. So write the whole word, all right? Since R prime of t is differentiable, it is continuous. And negative 6 is between negative 6.1 and negative 5.0. And then you repeat the prompt. I am just going to repeat what this says. Instead of is there a time t, though, I'm just going to say there is a time t, 0 less than or equal to t. I'm just copying it, for which R prime of t equals negative 6 by IVT. Did anyone get it? I think it was 2. You got a point for saying negative 6 is between these. So if you even said that, you got a point. And then you kind of needed like all the rest of it to get the second point, like the whole rest of the everything. But if you did the between part, you got a point. Let me see what you did.
Did say that, so 100%.
Differential is continuous math. Like,
Yeah, then you got them both. You all of your components are there. It's in a
Even
different
if I
order.
didn't repeat it, must be-
Oh,
That's the only problem, there must be a time to.
no, but you did it right there. There must be a time. Oh, well, I would generally time C on. Yeah, you were close. I see again, I would give you both. I feel like all the components were there. Okay. All right, letter C. Oh, everybody should have gotten this one too. Riemann sum with the 4 subintervals in the table. And again, you're gonna have to look at your paper because I don't want to keep sliding this paper up and down. All right, what'd you put? 3 times -5, good, plus 4 times -4.4, plus -3.8, plus. Did they ask for units or anything else, or is that it? That is it. That is worth 2.
And then the integral due to 12 are power to.
The only thing I'm gonna say about that, it took you time to write that. I wouldn't. It's not wrong. Like, but it's not wrong. All right, part D. Now, part D is a related rate. If you get a related rate on yours, you better hope it's like this, because this one wasn't bad at all. They gave you everything you needed. You don't have to go back and find anything. All right, let's make a list. The height decreases at a rate of 2 centimeters per day. That would be DHDT, but it's not 2, it's, but I coached you through that, so I think you're good on that. All right, then it says we're at times 3 days. You don't actually need that. They're just throwing that in there, right? Radius is 100. Height is 50. Again, I'm just reading off the paper. Are you all with? Did anyone make a list? Did you list this out? Okay. Find the rate of change of the volume. So what is our question mark? All right, dV dt is question mark. At time 3 days. All right, I think that's it. They give you the volume. It's right here. What rule do you need to get dV dt? Product. Good job. The first thing is 1/3 pi r squared. That is all the first thing. H is the second thing. All right. When we did this test, and this was back in like November, but I gave you ones that were exactly like this. All right. It's going to be the first thing, 1/3 pi r squared times what? dH dt. Good job. First times derivative of the second plus the second thing, which is just H. Derivative of the first, you would bring the 2 down. So it would be 2/3 pi r to the first. Good. dr dt. Nice job. That was worth 2. Yep. You can pull up the scoring guideline if you want, but I think it was 1 for doing a product rule. So if you had the format of a product rule, and then the second was if it was right. Okay. Now we're going to plug everything in. Ready? 1/3 pi, what is r? 100 squared. This is non-calculator, so please do nothing to this. All right, dH dt is -2. So there's all that. Plus, I think I went parenthesis crazy. I think I have an extra hug in there, but that's fine, whatever. All right, 50. All right, then we got 2/3 pi, r is 100, dr dt. They did give this to you. Good. dr dt is r prime, and we want it. Oh, I said we didn't need that it was time 3, but I guess we do need that. At time 3, -5. Did we need units? Did it say include units? Then don't put them. That was worth a point. For this one, you are just going to go through this point. You need to make sure you go all the way to the edges and just swim with the current, like you're following along with these. I'll be honest, I'm not like real great at this either. And I don't have an awesome like explanation, but does yours look basically like this? And then just make it go like all the way to the edges. So when I read the scoring guideline on this, And usually what it says is there's no obvious conflicts and it goes all the way to the edges. The other thing this one said, the places where it turns around have to be where those zero slopes are. Does that make sense? So like make sure wherever you turned is where the zero slopes are. That was worth 1 point. So if you did that, you got a point. Go ahead. Yeah, I think when I drew mine on here, they were off. Again, I'm not great at drawing. I'm sorry. Yeah, I think this one, yeah, you're right. I think this one was actually supposed to be like a little bit higher than the other one, because see that slope goes a little bit more. Yeah, it might be something more like that. Again, it says no obvious conflicts. So if you don't, basically you have to really mess it up to not get it. All right, what is B asking for? But before the approximation. Equation. What two things do we need for an equation? A point and a slope. All right, the point they gave to us, right? 1, 2. Slope comes from derivative, which is this thing right here. So we're going to plug in 1 for x and 2 for y. So it ends up being 1/2 sine pi over 2 times square root of 9. You're within your rights to just copy that over and leave it like that. They have to accept that. But for the sake of, I don't feel like writing that again, I'm going to actually work it out. What is sine of pi over 2? That's 1. This is 3. So 3/2. So your equation is y minus 2 equals 3/2 x minus 1. And then what are we plugging in for our approximation? Yeah, it's got to be close to 1, right? And then you add that 2 at the end. So it was a point for the equation and a point for the approximation. Yeah, you got it. You're within your rights to do that. I just don't feel like doing it. Yeah. You would lose that. So that is, I don't want to say a linkage error. It's a direction following error. Like you can't have, it's the difference between having an equation and having an equation with something plugged into it. Those are two different things. So you will lose that point. But again, you need to make those mistakes now and not be upset about it so that you won't make them. You need to make all your mistakes now so that you don't do them Monday. All right. It is known that second derivative is positive. What does that mean? What does second derivative talk to you about? All right. So this is concave up. So is this approximation that we just did overestimate or underestimate? Well, if I draw something concave up and here's my tangent line, that means my tangent line is below it. Do you see that? All right. So we're going to say under approximation because second derivative is positive on whatever it was. So f of x is concave up. Oh, underestimate is fine too. Yeah, whatever. Sorry, did I change it? I'm sorry. Whatever, means the same. Estimate, approximation. They wrote approximation right here and then estimate right there. So like those are interchangeable words. All right, that was only worth 1. But if you got it, you got it. If you mentioned something about concave up and therefore underestimate, then you're good. Did that go okay? Yeah, if you said underestimate and you mentioned something about second derivative being positive means concave up, then you got it. All the components were there. All right, what are your steps for the here? This is going to be on there too, like candidates test. You are going to do one of these. Let's do the steps. Separate, integrate, plus C, initial condition, and then find y, solve. Okay, so how do we separate that? Oh, we're going to have to divide this over. Oh gosh, I hate this already. What is your power for a square root? 1/2. When you divide this over, it becomes y plus 7 to the, now, oh, did you get that? Good job. Nice. dy. Did anyone else get that? A negative 1/2? Did you write 1 over square? You're correct as well. Did you write 1 over square root? Okay, that's perfect. Now you might need it this way in order to do an antiderivative. All right, equals whatever all the rest of that is. 1/2 sine pi over 2x dx. If you got that, you get a point. The next part's hard, so if that's the only one you got, I'm still proud of you. All right. Now you have to add 1 to the power, which instead of negative a half, that will make it positive a half, and that means out front, there's a 2. Equals antiderivative of sine. It is negative cosine. But wait, there's more. Pretend instead of a pi over 2, pretend it's a 5. That means out front you would need a 1/5. If it was a 12, you would need a 1/12. So again, first of all, this is negative, and out front you're going to need a 2 over pi. It's a U substitution, and that's your adjustment number. All right. Times 1/2 is sort of just there. Cosine of pi over 2x. Oops, I put the parenthesis in the wrong spot. And then at the end, plus c. Over here, positive.
Wait, can you explain why we had to do the number?
Yes. Well, the negative is because the antiderivative of sine is negative cosine. But again, this is a U substitution. If you were to write it out, which I recommend not doing, you would have U equals pi over 2x. You would have du equals pi over 2 dx, and you would multiply by a 2 over pi to cancel that out. Do you see what I'm saying? But I recommend against writing all of this. Just whatever number's in there, slap the reciprocal out front, and you're good to go. So if you have a guts of the problem here, just put the reciprocal of that out front. Now, good news, that was worth 2, and it was separate. So if you got this side, you got 1, and if you got this side, you got another one. So if you at least got this one, you're at your second point for this. Did anyone get this side? I think that was because you didn't write it the same way I did. Okay. What was our initial condition? Forgot at this point. 1 is 2. Oh, did you guys get through that? Yeah, nice. Okay. So we're going to plug in 1 for x and 2 for y. 2 plus 7. 9 to the 1/2. That means square root. So square root of 9 is 3 times 2, 6 equals. Okay. Cosine of pi over 2. We're plugging in 1 here. Cosine of pi over 2. 0. Good. So this whole thing goes to 0 plus c. So c is 6. You get a point for that. I like to believe that if you got one or the other of these right, I think if they were both wrong, you're sort of out. But I like to believe that, like, if you got one or the other of these right, and then this was correct based on that, that they would give you this point. All right. I'm like out of space. I'm going to have to go somewhere else. I'm going to recopy this line right above, except, you know what? I'm going to have to erase it. Don't do this on your AP exam, but I wrote too big. Okay. I don't want to be able to have you guys see this. I'm going to erase the plus c and put plus 6. Again, don't do that on your exam. Write another step. You'll have enough space. I just ran out of room. And now we're going to solve for y. The less writing you do here, the better. What would you do to start unburying the y? There's 3 steps. Divide by 2. You're going to take this entire thing and divide it by 2. All right, then what? Square it. I'm going to take this whole thing and square it. That gets rid of this 1/2. And then your last step.
If we just did that, like erase everything, but we don't need to like have the plugged in.
So if you had what I had, c equals 6, and then you put this on the next line, you're fine. Don't erase like I did. I just ran out of space. Okay. But what I did there with the divide by 2 and then erase it, as long as you did that on the next line down, you're totally good. All right, I have exactly 10 minutes. We can get through this last one. You ready? Particle motion. Particle P. I don't want to read to you. That teaches you to not read. What do they give you for particle P? Position. Keep reading. What do they give you for particle Q? Those are 2 different things. All right. And then for Q, they give you initial condition. All right, here we go. Part A. Find the velocity of particle P. How do you get from position to velocity? Because they give us position. Derivative. Derivative of 6? 0. That's gone. Derivative of e is itself. So it's going to be -4e to the negative t And then what rule do you need? You're going to chain on the derivative of negative t, which is -1. That's worth a point. Now you're within your rights to leave it like that. However, I think we may need that later on. So what is actually going to happen there to simplify that down? Yeah, those are going to cancel. So it's actually 4e to the -t. But that was just worth 1 point. They didn't in this case. And I think it's because they're not calling them that. They're calling them position, velocity, and acceleration. And also it spells it out very clearly in the problem. But again, do you understand what he's saying? Like, do you have to write that? You can always, I'm hurrying now because I want to finish this. You know, the scoring guidelines are free and you can Google them. So probably Google that before Monday. Okay. Also, you know that thing that I gave you that has the whole year listed out, like everything you've ever learned? Read that before Monday. I know that's not fun reading. All right. Here they want acceleration for particle Q. What'd they give us for Q? Oh, how do you get from velocity to acceleration? Okay, now it says 1/t². That's really t to the -2. So if you do that derivative, it will be -2t to the -3. And I think that's all you needed there. That's worth a point. But again, we're going to need that later on. How can I rewrite that so it's in kind of like a nicer... Yeah, that t³ can come down to the denominator. Oh, wait, is there more to part B? Oh, but wait, there's more. Find all times for positive t where the speed is decreasing. All right, how do you do speeding up or slowing down? Same sign, velocity and acceleration, same sign as speeding up, opposite signs slowing down. So we want opposite signs. Where's our velocity? Right here. This is going to always be positive. How do I know that? Squared. This is going to always be negative because we only have positive times and then there is a negative. So yeah, so we're going to say speed is decreasing 0 onwards for all times that are positive because, and then how would we say it? Velocity and acceleration are opposite signs there. And the only thing I'm going to add to that, and I would hope they would give this to you, but because there's a P and a Q, watch me do this. Put the little Q there and there. Do you get what I'm saying? Because I would be scared they wouldn't give it to you because they would be like, well, did you mean P or did you mean Q? You know, because they're mean, okay? And then that was worth 2. It said 1 point for looking at the signs and then 1 point for saying speed is decreasing, or you could say slowing down. But I feel like you would either get it or you wouldn't. You would probably get 2 or 0 for that. All right, find the position for particle Q. Remember the monkey and the gopher where you started plus what you accumulated? What was that initial condition? 2. So you're going to have 2 plus integral. Where does it start? Because it's not 0. 1 to wherever of your velocity, which was t to the -2. Now there should be 2 different letters of the alphabet. For example, if t is what's inside the integral, that shouldn't also be t. I'm just going to go with it though. Okay. And if your answer's right, they're going to give it to you. You could call one or the other of them x if you want. I'm going to just leave it alone for right now. All right. So this is 2 plus antiderivative. You have to add 1 to the power. So be careful because it's negative. It's going to be -1. And that means you need a -1 out front such that 1 to t. Now I'm going to erase. How can I rewrite this so there's not a negative power? Because I don't want a negative power. Yeah, so it'll go to the denominator, but it'll look like what? Yeah, -1 over t. And then so your final answer is 2 plus upper minus lower. And set it up blank. If you plug in t, you just get -1 over t. And then if you plug in 1, you get -1. So it is oh wow, this was worth a boatload of points. if you used the initial condition, so if you wrote 2 plus bananas, you got a point. If you set up this integral, you didn't even have to do the antiderivative. If you set up this integral, you got a point. You didn't even have to do any math. Basically, if you set it up, you got 2 points. And then if you got all the way to the answer, you got a point. I kind of like that. If you set it up, you got 2. That's pretty good. All right, last one. We can make it. It says, as time goes onwards, what does that feel like to you? It feels like a limit. You're right, because it is, all right? Which particle will eventually be further away from zero? Is that position or velocity? Good, it's where it is, all right? So we're gonna do limit as time goes to infinity for position of particle P. There are a million different things going on here. You have position, velocity, and acceleration for 2 totally different particles. What is position for P? Yeah, this thing, right? All right, and then we're gonna do limit, time goes to infinity, position for particle Q, which is this right here. So unfortunately, if you couldn't get it in part C, you're not really gonna be able to do part D. Also, let's clean this up. What would that be? 3 minus 1 over T? Let's do that one first. If you think about plugging in the most enormous number you can possibly imagine, what does this part go to? 1 gazillionth. 0. So it's 3 minus nothing, which is 3.
Should that be, an approximation?
Nope. That's me. All right, the same thing is going to happen with this one. If you want to think of this as 4 over e to the t, that's what the negative power is. If you think about plugging in the largest number you can possibly imagine, you get 4 over 100 bazillion gajillion million. So that's 0. So 6 minus 0, which is 6. So what is your sentence that's the answer to the whole thing? Particle, which one? Particle P is further as time goes to infinity because 6 is bigger than 3. That's what it said on the scoring guideline. I feel like that's obvious. 6 is bigger than 3. So it was 1 point for doing these limits and then 1 point for writing the sentence. I'm going to say this while it's still recording. Google is free. You can Google all of the released exams. I do not recommend using 2020 or 2021 though. Okay. Now we've gone backwards. We did 24, 23, 22, but you can go backwards. You can bring up 2019, 2018. You can bring up the scoring guidelines. That's all available online. Okay.